Hello all, I am Dr. Lakshmi Sharma, Assistant Professor, Department of Physics, Brijlal Biani Science College, Amravati. I welcome you all in my e-class. This class is about laser. Laser, light amplification by stimulated emission of radiation. Here I cover the topic absorption of light, spontaneous emission of light, stimulated emission of light. Light is a form of energy. Light energy has value multiple of photon energy h. H is Planck's constant, nu be the frequency of light. One more thing, electron revolves in different orbit. These permitted orbits are characterized by allowed energy levels. Lower energy state is known as ground state, denoted with E1. Higher energy state is known as excited state, denoted with E2. Absorption and emission of light. Absorption. Transition of electron from ground state to excited state. Emission. Transition of electron from excited state to ground state. Types of emission. There are two types of emission, spontaneous emission and stimulated emission. Electron cannot stay in outer orbit for a longer time. Electron returns to the ground state. Excited electron loses its excess energy. This type of emission is known as spontaneous emission. It is responsible for light coming from sun, fire, bulb, candle, that is conventional sources of light. As in laser, there is a stimulated emission. An atom in excited state need not wait for spontaneous emission to occur. If a photon with energy h nu interacts with excited atom, it can trigger the atom to undergo transition to lower level and emit another photon. It is responsible for light coming from laser source. Here, three diagrams. One is for absorption, second is for spontaneous emission, third is for stimulated emission. In all diagrams, E1 represent lower energy state, E2 represent higher energy state. In first diagram, electron absorbs some light energy and goes to excited state. Transition of electron from lower energy state to higher energy state by absorbing incident photon. A plus h nu equals to A star. A electron in ground state, h nu energy of incident photon which is absorbed by the electron in ground state, A star electron in excited state after absorbing energy. In second diagram, electron which is in excited state transit from excited state to ground state emitting a photon. A star equals to A plus h nu. A star electron in excited state, A electron in ground state, h nu emitted photon. In third diagram, stimulated emission happens. Here we see two photons. One photon is used to trigger the electron from higher state to lower state. And in this transition, excess energy is also emitted. Hence, there are two photons. Electron from excited state transit to ground state with the help of a photon and emits photon. This is stimulated emission. A star equals to A plus 2 h nu. That is, In stimulated emission, we get two photons. That is, photons are multiplied. Photons are amplified. Here I explain electron transit from lower energy state to higher energy state by absorption. Electron transit from higher state to lower state by emission. Emission are of two types: spontaneous emission and stimulated emission. Spontaneous emission is responsible for light coming from ordinary source. That means when we switch on the bulb, light we get is due to the spontaneous emission. Electron transit from higher energy state to lower energy state emitting a energy in the form of light. This light, or say this kind of photon, is radiated in all directions. But in case of a laser, stimulated emission is responsible. Stimulated emission is responsible for light coming from laser source. Here, when electron transit from higher state to lower state with the help of a triggering agent, it emits a photons which are exactly identical with each other. They are same state of polarization, having same phase, same frequency, and that is nothing but the laser. Light amplification by stimulated emission of radiation. Light coming from laser is coherent, unidirectional, monochromatic, and highly intense. Thank you.